Sum and difference formulas. This video is about evaluating trigonometric expression, evaluating trigonometric function, rewriting a trigonometric expression as sine, cosine, and tangent. Sum and difference formulas. Sine of u plus v is sine u times cosine v plus cosine u times sine v. Sine of u minus v is sine of u cosine v minus cosine u sine v. And cosine u plus v is equal to cosine u cosine v minus sine u sine v. Cosine u minus v equal to cosine u cosine v plus sine u sine v. And tangent u plus v is tangent u plus tangent v. 1 minus tangent u tangent v. And tangent u minus v is tangent u minus tangent v over 1 plus tangent u tangent v. So if you write these formulas a few times, you can memorize. Unit circle. For angle theta, there corresponds a point x in the unit circle, where x is a cosine theta and y is a sine theta. For example, this one here, the angle is 2 pi over 3, and the point is negative 1/2 and square root of 3 over 2. So this is cosine theta, and this is a sine theta. Also in rectangle coordinates, this is x and this is y. Some guidelines to find the exact values of trigonometric functions. If the angle of trigonometric function is in the unit circle, then use the unit circle values, because if you use a calculator, you will get approximate results and it will be counted wrong. If the angle of trigonometric function is not in the unit circle, then write the given angle as a sum or difference of two angles which are in the unit circle. Then use the appropriate sum or difference formula to write an equivalent expression, and use the values from the unit circle and simplify. Here's an example. We want to find sine of 135 degrees minus 30 degrees. So we can say let u 135 degrees and v is 30 degrees. And we can use the different formulas. And the different formula is sine of u minus v is equal to sine u cosine v minus cosine u sine v. Now we substitute u is equal to 135 degrees, v is equal to 30 degrees. So this formula becomes sine of 135 degrees minus 30 degrees equals to sine of 135 degrees cosine of 30 degrees and minus cosine 135 degrees sine 30 degrees. Now on the unit circle, for theta equals 135 degrees, so 135 degrees, and which is this one, there is a point negative square root of 2 over 2 and the square root of 2 over 2, where square root of 2 over 2, negative square root of 2 over 2 is cosine 135 degrees, and square root of 2 over 2, that is sine 135 degrees. And on the unit circle for theta equals 30 degrees, there is a 30 degrees, and there is a point here, which is square root of 3 over 2 comma 1/2, where cosine 30 degrees square root of 3 over 2 and sine 30 degrees 1 over 2. Now we have sine 135 degrees minus 30 degrees is equal to sine 135 degrees cosine 30 degrees minus cosine 135 degrees sine 30 degrees. Now we substitute sine 135 is equal to square root of 2 over 2 cosine 135 minus square root of 2 over 2. Sine 30 is 1/2 and cosine 30 is square root of 3 over 2. So we have the square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So we multiply, it becomes square root of 2 times square root of 3 is square root of 6 over 2 times 2 is 4. Minus minus become plus. Square root of 2 times 1 is square root of 2, and 2 times 2 is 2, 4. Same denominators. We write the denominator 4 and we add the numerator square root of 6 plus square root of 2. Okay, example 1b. So now we're going to find sine 135 degrees minus sine 30 degrees. On the unit circle for theta 135 degrees, there is a point right here, minus square root of 2 over 2, square root of 2 over 2, where cosine 135 is minus square root of 2 over 2, and sine 135 is square root of 2 over 2. Similarly, on the unit circle for theta equals 30, there is a point, this one, square root of 3 over 2, comma 1/2. So where cosine 30 degree is square root of 3 over 2, and the sine 30 degree is 1/2. So now we have sine 135 degrees minus sine 30 degrees. Now we substitute sine 135 degrees is equal to square root of 2 over 2, and sine 30 is 1/2. So we have square root, this equals to square root of 2, 30 is 1/2, same denominators, and we can subtract the numerator. So we have a square root of 2 minus 1 over 2. So this result is different than the sine 135 minus 30 degrees. Example 2. So we're going to find the exact value of the trigonometric function a sine of 3 pi over 4 plus pi over 6. So here u is 3 pi over 4 and v is pi over 6. And we can use the sum formula sine u plus v is equal to sine u cosine v plus cosine u sine v. And now we can substitute u is equal to 3 pi over 4, v is pi over 6 in this formula, and we'll get sine of 3 pi over 4 plus pi over 6 equal to sine 3 pi over 4 cosine pi over 6 plus cosine 3 pi over 4 sine pi over 6. So now we can get these values, sine 3 pi over 4. So 3 pi over 4 is right here, and the second coordinate is gives you what? Square root of 2 over 2. And we need the cosine 3 pi over 4, which is x, and that's the minus square root of 2 over 2. And then have a sine pi over 6, the sine pi over 6 is 1/2, and cosine pi over 6 is square root of 3 over 2. So now we write sine 3 pi over 4 plus pi over 6 equal to, so sine 3 pi over 4 is the square root of 2 over 2, cosine pi over 6 is square root of 3 over 2, plus cosine 3 pi over 4 is negative square root 2 over 2, sine pi over 6 is 1/2. Now we can multiply square root of 2 and square root of 6. 2 times 2 is 4 minus square root of 2 times 1 is square root of 2. 2 times 2 is 4. Now we write the 4 and subtract square root of 6 minus square root of 2. B part, we want to find sine 3 pi over 4 plus sine pi over 6. So 3 pi over 4 is right here, and the second coordinate y is the square root of 2 over 2. Sine pi over 6, the second coordinate of this point is 1/2. And same denominators we can add square root of 2 plus 1 over 2. So it looks like this answer is different than this answer. So we can conclude the sine of 3 pi over 4 plus pi over 6 different than sine 3 pi over 4 plus sine pi over 6. So here is an example 3. We're going to find the exact values of sine, cosine, and tangent of the angle. A, cosine of 135 degrees minus 30 degrees. So we have to find the exact value of cosine 135 degrees minus 30 degrees. So here u is equal to 135 degrees and v is 30 degrees. So we're going to use the some formula cosine u minus v, which is cosine u cosine v plus sine u sine v. So when I substitute u to 135, v is 30 degree. So this becomes cosine 135 degrees minus 30 degrees is equal to cosine 135 degrees cosine 30 degrees plus sine of 135 sine 30. Now this is same as the given. So this is equal to this one, and now we need to substitute the values. Well, for 135 degrees, so we look at 130 degrees right here, and the cosine is the first coordinate, which is minus square root of 2 over 2, and the sine 135 degrees second coordinate, which is square root of 2 over 2. Similarly, we need a sine 30 degrees and cosine 30 degrees. So we go to 30 degrees angle. This is the point, and sine 30 degrees is the second coordinate, which is 1/2, and the cosine 30 degrees is the first coordinate, square root of 3 over 2. So now we substitute these values in this formula. So we have a cosine 135 degrees minus 30 degrees equals to cosine 135 is a negative square root 2 over 2. Cosine 30 is square root of 3 over 2 plus sine 135 is square root of 2 over 2 times sine 30 is 1/2. So now we simplify. So this becomes negative square root of 6 over 4, and this becomes plus square root of 2 over 2. So I'm going to combine this one. So we have minus square root of 6 plus square root of 2 over 4. Now we find cosine 135 and cosine 30. Cosine 135 is the first coordinate, negative square root of 2 over 2, minus cosine 30 is the first coordinate of this point, which is square root of 3 over 2. So now we same denominator, so we write the denominator 2, and we combine this minus square root 2 minus square root of 3, which you can factor or negative, gives you square root of 2 plus square root of 3. Again, they are different. So here is example 4. We're going to find the exact value of cosine 135 degrees plus 30 degrees. Again, u is 135 degrees, v is 30 degrees, and we can accordingly we can apply this formula. Cosine u plus v equals to cosine u cosine v minus sine u sine v. And we substitute u 135 degrees with 30 degrees. So we have a cosine 135 degrees minus 30 degrees equal to cosine of 135, cosine of 30, minus sine of 135 and sine 30. Now we substitute the values. Sine 135 degrees, which is for a second coordinate of this point, so which is square root of 2 over 2. And cosine 135, the first coordinate of this point, which is minus square root of 2 over 2. Sine 30 is the second coordinate of this point, 1/2, and cosine 30 is square root of 3 over 2, the first coordinate of this point. So we substitute these values, so we get it's equal to minus square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So we get multiply these two, become 4 minus square root of 6, become minus square root of 2 over 4. 4 is the common denominator, so we write 4 and we just combine minus square root of 6 minus square root of 2. Now b cosine 135 plus cosine 30. Cosine 135 again, the first coordinate of this point, minus square root of 2, cosine 30 is the first coordinate of this point, square root of 3 over 3, right, together, and then we combine negative square root of 2 plus square root of 3. So they are again different. So here is an example 5. We're going to find the exact values of sine, cosine, and tangent of this angle, 150 degrees. So let's first find the sine of 150 degrees. So sine of 150 degrees, so this equals to sine of 90 plus 60. Now so we can decide which formula to use, since this matches with the sine u plus v, with u 90 degrees and v 60 degrees. So it looks like we can apply this formula. Sine u plus v equals to sine u cosine v plus cosine u sine v. Now we substitute u 90 degrees and v is equal to 60 degrees. So we have a sine of 90 degrees plus 60 degrees is equal to sine of u is 90 degrees, cosine of v is 60 degrees, plus cosine of u is 90 degrees, and sine of v is 60 degrees. So from the unit circle, now we get on sine 90 degrees is 1, cosine 60 is 1/2, cosine 90 is 0, and sine 60 is square root of 3 over 2. So we substitute these numbers in, so we get sine of 150 degrees equal to sine 90 is 1, cosine 60 is 1/2, plus cosine 90 is 0, and sine 60 is square root of 2 over 2. Well, this becomes 0, so we have 1 and 1/2 is 1/2 plus 0, so the answer is 1/2. So sine of 150 degrees actually 1 over 2. So we're going to find the exact value of cosine of this angle 150 degrees, which is expressed as 90 degrees plus 60 degrees. Now, so we have cosine of 150 becomes cosine of 90 plus 60, and now this matches cosine u plus v, with u 90 degrees and v 60 degrees. But cosine u plus v is equal to cosine u cosine v minus sine u sine v. Now we substitute u is equal to 90 degrees and v is 60 degrees. So we have cosine 150 degrees equal to cosine of u 90 degrees plus v 60 degrees. So now this is equal to cosine of u, which is 90 degrees, cosine of v is 60 degrees, minus sine u is 90 degrees, sine v is what? 60 degrees. Now with cosine from the unit circle, cosine in 90 degree is basically 0, sine 90 is 1, and cosine 60 is 1/2, and sine 60 is square root of 3 over 2. So cosine 150 degree becomes sine 90 is 0, cosine 60 is 1/2, minus sine 90 is 1, and sine 60 is square root of 3 over 2. But this goes to 0, so you'll have to be negative square root of 3 over 2, which is minus square root of 3 over what? 2. Here we're going to find the exact value of the tangent of this angle. 150 degree, which expresses 90 degrees plus 30 degrees. So we take the tangent of this, so it becomes tangent 150 equals to sine 150 or cosine 150. From part A, sine 150 is 1/2, and cosine 150 is equal to what? Square root of 3 over 2, negative square root of 3 over 2. So this formula becomes sine 5 minus square root of 3 over 2, which is 1/2 multiplied by the square root by the reciprocal, which is 2 over square root of 3. So here multiply gives you negative 2 and 2 cancel with you negative 1 over square root of 3, which you rationalize becomes square root of 3 over 3 with negative sign. Okay, so here's an example 6. Write the expression as sine, cosine, or tangent of the angle. So we have sine 5 pi over 7 times cosine 4 pi over 5 plus cosine 5 pi over 7 sine 4 pi over 5. So if you look at this one, so you might recognize this expression matches this formula sine u cosine v plus cosine u sine v, which is equal to sine of u plus v, where u is equal to 5 pi over 7 and v is equal to 4 pi 5. So this formula it becomes sine u plus v. Now we substitute u is equal to 5 pi over 7 and v is equal to 4 pi over 3. So this becomes sine of u plus v becomes sine 5 pi over 7 plus sine plus 4 pi over 5. Now we have to add all this. So LCD is 35. So here we multiply 5 top and bottom, and here 7 top and bottom. So we got sine of 25 over 35, and then plus becomes 28 pi over 35. So this we can add. So it will be 25 plus 28 pi over 3 pi over 35. So this is equal to sine of 53 pi over 35. So here is example 7. We're going to write the expression as sine, cosine, or tangent of the angle. So we have sine 5 pi over 7 times cosine 4 pi over 5 minus cosine 5 pi over 7 and sine 4 pi over 5. So if you look at this expression, you can recognize this expression matches the formula sine u cosine v minus cosine u sine v, which is equal to sine u minus, and for u is equal to 5 pi over 7 and v is equal to 4 pi over 5. So now we can write this one sine of u minus v, where we can substitute u is equal to 5 pi over 7, v is equal to 4 pi over 5. So this expression is reduces to sine 5 pi over 7 minus 4 pi over 5. Now we just combine. So we multiply top and bottom by 5 here, 5 here, to top and bottom 7, because LCD is what? 35. So this becomes sine of 25 pi over 35 minus 28 pi over 35. Same denominator, we write the denominator and we combine 25 minus 28 pi, which is minus 3 pi. So this expression reduces to sine of negative 3 pi over 35. So here is example 8. We're going to write this expression cosine 5 pi over 7 times cosine 4 pi over 5 minus sine 5 pi over 7 times sine 4 pi over 5. Now this expression matches the formula cosine u cosine u cosine v minus sine u sine v, which is equal to cosine u plus v. And for u is equal to 5 pi over 7, v is 4 pi over 5. So we can write this equal to sine u plus v. So where now we substitute u is equal to 5 pi over 7, v is equal to 4 pi over 5. So this becomes cosine 5 pi over 7 plus 4 pi over 5. Now LCD is 35. So we have to convert, replace 7 with 35. So we multiply 5 and 5, 5 on the top, 5 on the bottom. And then here we can multiply top and bottom 7 and 7. Now we simplify, you get cosine of 25 pi over 35 plus 7 times 4 by 28 pi over 35. And now we rewrite this one as cosine of 35 is the denominator, and we can add 25 plus 28, which is 53 pi. So the answer is cosine of 53 pi over 35. So here is an example 9. We're going to write this expression cosine 5 pi over 7 cosine 4 pi over 5 plus sine 5 pi over 7 sine of 4 pi over 5 as sine, cosine, or tangent of the angle. So you recognize that this expression cosine 5 pi over 7 cosine 4 pi over 5 plus sine 5 pi over 7 sine 4 pi over 5 matches this formula cosine u cosine v plus sine u sine v, equals to cosine u minus v for u equal to 5 pi over 7 and v is equal to 4 pi over 5. So we can apply this formula on this one. We can rewrite cosine u minus v and substitute u is equal to 5 pi over 7 and v is equal to 4 pi over 5. So this becomes cosine 5 pi over 7 minus 4 pi over 5. Now we have to subtract, find the LCD, which is 35. So we're going to convert this denominator equal to 35. So here we multiply 5 over 5 and divide by 5. And here we multiply 7 and divide by 7. So now we simplify, we get cosine of 25 pi over 35 minus 28 pi over 35. And now we denominator is 35, so we're going to subtract 25 minus 28 pi is minus 3 pi. So we have a cosine of negative 3 pi over 35. So here is example 10. We're going to write this expression tangent 5 pi over 4 minus tangent pi over 12 over 1 plus tangent 5 pi over 4 tangent pi over 12. Now this expression matches with this formula tangent u minus tangent v over 1 plus tangent u tangent v, which is equal to tangent u minus v. For u equal to 5 pi over 4 and v is equal to pi over 12. So we can write this equal to tangent u minus v and substitute u equal to 5 pi over 4 and v is equal to pi over 12. And this becomes tangent 5 pi over 4 minus pi over 12. Now here LCD is 12. So to convert 4 to 12, we multiply 3 top and bottom. So we have a tangent 3 over 3 times 5 pi over 4 minus pi over 12. Simplify to tangent 15 pi over 12 minus pi over 12, which is tangent of 14 pi over 12. Example 11, we're going to write this expression tangent 4.9 plus tangent 1.7 over 1 minus tangent 4.9 times tangent 1.7 as the sine, cosine, or tangent of an angle. So if you look at this expression, matches this formula tangent u plus tangent v over 1 minus tangent u tangent v, which is equal to tangent u plus v. For u equal to 4.9 and v is 1.7. So we can apply this formula on this one. So we can write this equal to tangent u plus v and substitute u equal to 4.9 and v is 1.7. So this is equal to tangent 4.9 plus 1.7, which is tangent 6.6. So here is example 12. We're going to write the expression sine 3x cosine 2y plus cosine 3x sine 2y as the sine, cosine, and tangent of the angle. So recognize that this expression sine 3x cosine 2y plus cosine 3x sine 2y matches sine u cosine v plus cosine u sine v equals to sine u plus v for u equal to 3x and v is equal to 2y. So we apply sine u cosine v plus cosine u sine v plus sine u plus v formula. So we can write this equal to sine u plus v and substitute u is equal to 3x and v equal to 2y. So this becomes sine 3x plus 2y. So we can write this expression sine 3x cosine 2y minus cosine 3x sine 2y as a sine, cosine, or tangent of the angle. We recognize that this expression sine 3x cosine 2y minus cosine 3x sine 2y matches sine u cosine v minus cosine u sine v equal to sine u minus v for u equal to 3x v equal to y. So we can apply this formula sine u cosine v minus cosine u sine v equals sine u minus v. So this is equal to sine u minus v, and we substitute u is equal to 3x, v is equal to 2y. So this becomes sine of 3x minus 2y. So here is example 14. We're going to write this expression cosine 3x cosine 2y minus sine 3x sine 2y as the sine, cosine, or tangent of the angle. Recognize that this expression cosine 3x cosine 2y minus sine 3x sine 2y matches cosine u cosine v minus sine u sine v equals to cosine u plus v for u equal to 3x, v equal to 2y. So we can apply this cosine u cosine v minus sine u sine v is equal to cosine u plus v. So we can set this equal to cosine u plus v for u is equal to 3x and v is equal to 2y. So we substitute u is equal to 3x and v is equal to 2y. So this becomes cosine of 3x plus 2y. So this expression is expressed as a cosine of 3x plus 2y. So here is example 15. We're going to write this expression cosine 3x cosine 2y plus sine 3x sine 2y as a sine, cosine, or tangent of the angle. So if we recognize that this expression cosine 3x cosine 2y plus sine 3x sine 2y actually matches cosine u cosine v plus sine u sine v equal to cosine u minus v for u equal to 3x and v is equal to 2y. So we can apply cosine u cosine v plus sine u sine v is equal to cosine of u minus v. So with this we can write this is equal to cosine u minus v for u is equal to 3x and v is equal to 2y. So now we substitute u is equal to 3x here and v is equal to 2y. So this becomes cosine of 3x minus 2y.